For every successful aircraft, there were many more that never made it beyond the drawing board. Some of these designs failed due to cost, time constraints, a lack of interest, or just plain bad luck. But some were the victims of their own lofty ambitions. Today we're going to look at some of the crazier commercial aircraft designs that never quite made it. And seeing as flying boats are some of my favourite aircraft designs, let's start off with a couple of them, both of which were designed at Saunders Roe. First up is the Duchess. Even before the Second World War had wrapped up, the British Air Ministry was keen to revive the famous flying boat air routes. Saunders Roe, often known simply as SARO, had foreseen the need of increasingly larger flying boats in the post-war era, and were endeavouring to design and build the Princess. The Princess will get its own video, as that was an aircraft that at least actually flew, but along with this aircraft they were also working on something more cutting edge. The jet age had well and truly dawned, and SARO were designing a new aircraft to feature this technology, the Duchess. The Duchess was designed as a medium-range flying boat, with the intention to carry up to 6 crew and 74 passengers across a distance of 2,600 miles. It had a length of 124 feet 6 inches, a wingspan of 129 feet, and a maximum takeoff weight of 130,000 pounds. It was envisioned to have a top speed of 550 miles an hour and a cruising speed of 468 miles an hour, which was considered pretty brisk by late 1940s standards. To move the Duchess through the air at such speeds, it was designed to be powered by 6 of the reliable de Havilland Ghost turbojets, which provided 5,000 pounds of thrust each. The engines would be mounted in the wing roots, 3 to each side, with removable panels over the installations to facilitate maintenance. Up to 3 fuel tanks were to be provided, with 6,000 gallons being contained in the 2 main tanks in the outer wing sections, and an optional 1,250-gallon tank in the centre section of the wing. The wings were mounted high on a visually distinctive hump, so as to reduce the risk of water entering the engines, which for a seaplane is something you sort of wanted to avoid. The sweepback on the inner sections of the wing was greater than the outer sections to achieve the high speeds required, and the tailplane also had a significant sweepback for the same reason. Its hull form was unusual for a flying boat, as its length-to-beam ratio was pretty high compared to the contemporary designs. With the engines mounted so close to the centre, they could not be relied on to provide sole lateral control when the Duchess was on water, and as a result of this, a split water rudder was included at the bottom of the tail. The Duchess would remain a paper aircraft, as the need for flying boats waned during the late 1940s and into the 1950s, but it wouldn't be the only jet-powered flying boat Saunders Roe designed. Enter the Saunders Roe Queen, and yes, she is a big one. In fact, it should really be considered a cruise ship with wings, seeing as SARO had been contracted by P&O to design her. The intention was to provide the same facilities and standards of comfort that were enjoyed by those travelling by sea. Now, due to the sheer size of this aircraft, only long routes would justify the expense of such an endeavour, and so the Queen was designed to fly from the United Kingdom to Australia. The numbers of this mammoth are pretty damn impressive. She was expected to have a capacity for 47 crew members and 1,000 passengers. She had a length of 318 feet, a height of 55 feet 9 inches, and a wingspan of 313 feet. Her maximum takeoff weight was predicted to be 1,500,000 pounds, and all of this was to be powered by no less than 24 Rolls-Royce Conway engines. Astonishingly, a complete design plan was actually drawn up for this aircraft, and like the Princess, I'll do a full video on this monster in the future. Sadly, that might take a while, as I'm on a waiting list to get copies of her design documents sent to me by the National Archives, and requesting copies from half the way around the world is turning out to be rather difficult. Next up, we have a design from Junkers. Before Junkers worked on their famous G-38 aircraft, they had produced an exploratory, revolutionary, and massive design called the J-1000. Indeed, lessons learned from designing this aircraft directly affected the design process of the G-38s themselves. The J-1000 was designed way back in 1924, and it was the brainchild of a design team led by Otto Mader. It followed Hugo Junkers' pioneering principles of using a thick, load-bearing wing as the main structure for the aircraft. It had a wingspan of 80 meters, a length of 24 meters, and a height of 7.5 meters. The wing itself was constructed of a tubular frame with duraluminum cladding, and it had a maximum thickness of 2.3 meters. Jutting out at the front central section was the so-called command post, which housed the cockpit and navigation room. And like the G-38 of future years, the J-1000 was designed to have literal engine rooms in the wing, which allowed mechanics to service the aircraft in flight. Initially, it was designed to be powered by a system of 4 1,000 horsepower piston compressor engines, the propellers being driven by 4 turbines that would be connected to storage tanks containing compressed air. At some point, this system was changed out in favour of 4 2,000 horsepower diesel engines. Though the exact reason for this change is unknown, it was probably done for the sake of increased power output and reduced complexity. The so-called tail of this aircraft actually sat in front of the cockpit. It consisted of a large horizontal control surface that sat atop the ends of 2 hull-like structures. These structures housed dining rooms and viewing platforms for up to 18 passengers, as well as the structure for the landing gear. The landing gear itself was designed to be retractable, a very cutting-edge concept in 1924. In the event of a gear failure, the structure of these hulls was heavily reinforced to support the impact of a hard landing. The design of the J-1000 had been prompted by Hugo Junkers himself, who wanted a revolutionary design to take over to America. He took the design with him, along with full blueprints, renderings, and even some models. But ultimately the aircraft was too big and too ambitious for its time, and Junkers failed to secure any investors for the construction of a prototype. Out of all the aircraft featured in this video, the Airliner No. 4 is perhaps the most fantastical of the lot, though the Saunders Roe Queen is definitely a contender when it comes to sheer size. It was designed between 1929 and 1932 by Norman Bell Geddes and Otto Koller. Geddes and Koller did not see eye to eye when working together. They had in fact disagreed on a previous design, and as a result of this, Otto refused to provide exact performance specification for the new design here. So take the figures provided by Norman with a grain of salt. Now Norman had a bit of a thing for designing vehicles and things in general of a bulbous shape, and the Airliner No. 4 is perhaps the best example of this obsession. Whether this aircraft had a remotely safe aerodynamic design is still up for debate, though it's not wholly improbable. But its sense of grandeur cannot be overstated. It was designed as a very large, tailless, V-winged amphibious monoplane. The airliner had a wingspan of 528 feet 5 inches, and was supported by 2 large pontoons that were 104 feet apart and 60 feet high. It had a gross weight of 1,275,300 pounds, and it was powered by 20 engines that provided a total combined output of 38,000 horsepower. Ideally, it was to carry 451 passengers and 155 crew in singular luxury. The airliner was designed with every comfort in mind, and with 9 dedicated decks it certainly had the space for it. 4 of these decks were built into the 2 large pontoons, with each deck coming as a pair. The first decks carried the main fuel tanks, from which fuel would be pumped up to auxiliary fuel tanks that would feed directly into the engines. Half of the second decks were also devoted to fuel storage, as well as housing pumps and baggage compartments. The third decks provided entrances for baggage and passengers depending on which side, information desks, office suites for the purser and stewards, crew quarters, and the crew's kitchen as well as a mess hall. The fourth decks both had forward lookout stations, and between them they also held the main kitchen, pantry, and supply rooms, which in turn would supply the 12 other pantries and 2 auxiliary kitchens that were scattered around the airliner. At the back of the fourth decks were 6 motorized lifeboats which could be boomed out on pontoons. The remaining decks, barring the engine room, were in the main hull of the airliner. Deck 5 featured a huge main lounge that had a 36-foot high ceiling and could accommodate such things as a full orchestra and dance floor. The rear of this lounge featured a dining room that could comfortably seat 200, and attached to this would be 3 smaller private dining rooms as well. Deck 6 housed a gymnasium, solarium, children's playroom, medical facilities, and a hairdresser's shop. Deck 7 was known as the promenade deck, as it ran almost the full length of the main wing and provided excellent viewing opportunities for the passengers. It also featured cafes, a bar, bathing facilities, and 14 suites that had their own private verandas. Deck 8 held the navigation bridge, chart room, officers' quarters, and the radio room. Deck 9 formed the interior of the auxiliary wing, which sat above the main hold. It's where the engines were mounted, and it contained the engine rooms, repair shops, and additional equipment storage. Not surprisingly, an aircraft of this size, equipped with the technology of the time, wasn't going to be the swiftest bird in the sky. It had a theoretical top speed of 150 miles an hour, and a cruising speed of between 90 to 100 miles an hour. It was expected that a flight from Chicago to Plymouth would take 42 hours, and the aircraft would require refueling during this time. It was never completely verified whether or not they intended to refuel this behemoth mid-flight, but the safest option would involve an amphibious refueling operation rather than the insanity of refueling this thing in the air. It was estimated that the airliner would cost around $9 million to build in 1932, and by making 3 Atlantic crossings per week, it could hope to pay for itself within 3 years, which was pretty good for the time. For various reasons, size, cost, aerodynamics, and an inclination for sanity, it was never built. Now, the remaining aircraft in this video don't have as much documentation about them, but they're still worth honourable mentions, starting with the Boulton Paul P-144. Near the end of their operating life, Boulton Paul began to work on designs for VTOL aircraft. In fact, they were quite prolific with this, drawing up over a dozen designs during the 1950s. The two most striking of these were the P-144 and the P-146. The 144 was more akin to Boulton Paul's idea for a flying car or a private shuttle rather than a traditional aircraft, being designed to only carry 5 passengers or a cargo payload of 1,000 pounds. It was to be powered by 2 Rolls-Royce engines that drove 4 fans, 2 in each wing, well, if you can call them wings. They had a greater chord than span, giving it a somewhat bug-like appearance. It had a length of 27 feet 9 inches, a width of 17 feet 6 inches, and a height of 13 feet 6 inches. It was designed to have an approximate top speed of 184 miles an hour and an endurance of 50 minutes. A second version, dubbed the 144A, was also drawn up, which apparently looked much more like a car. It had a jet engine for flight and a traditional piston engine for ground use. Now, the P-146 was Boulton Paul's grandest and most outlandish of VTOL designs, and frankly it looks like something straight out of Thunderbirds, which I absolutely love. It was a 96-seat VTOL civil airliner with tandem-swept wings and powered by 3 modified RB-163 bypass engines, along with 18 RB-155 lift engines as well. The 3 engines that were used for more conventional flight were mounted around the rear of the fuselage, whilst the 18 lift engines were mounted in 4 pods on the tips of the wings and the forward canards. This design never made it past the initial concept stages, with only a single marketing model being produced. Up next, we have the Tupolev 404, a relatively recent design that was started in 1991. Initially, this design began as a more conventional-looking aircraft, somewhat resembling an upscaled Boeing 747. But the passenger cabins posed design problems, and so the decision was made to change it to a blended wing design instead. In this new form, the main cabin was huge, having a width of 27 meters at its widest point. The vast floor and roof were joined by numerous struts or walls to withstand the pressurization loads. The 404 had a wingspan of 110 meters, a length of just under 60 meters, and was designed to carry over 1,200 passengers with a maximum range of 13,500 kilometers. Curiously, this aircraft was to be powered by turboprops rather than jet engines. 6 engines were to be mounted in the tail section of the fuselage between 2 large vertical stabilizers. In 1993, Tupolev exhibited the large model of this aircraft in its flying wing configuration, with a projecting cockpit near the nose, widely spaced slanting tails with underfins, and 6 advanced turboprop engines. Despite some general interest in the project, there was not enough to justify it going beyond marketing models and hypothetical discussions. And last, but certainly not least, we have the Rolls-Royce Griffith projects, a supersonic vertical takeoff airliner that looks like something straight out of a sci-fi movie. In fact, it could also possibly be the inspiration for a certain aircraft featured in the Star Wars universe. There seems to be no one single design for this aircraft, but a series of patents were lodged by Alan Arnold Griffith, whom the project is unofficially named after. The exploration of these patents resulted in a supersonic jet transport that was proposed in the late 1950s. It was designed out of a growing need for large transports that could operate at high altitudes and at high speeds in excess of 500 miles an hour. One of the proposed designs would be powered by a grand total of 68 jet engines. 56 of these would be installed in the main fuselage to provide vertical thrust, and the remaining 12 engines would be mounted in the tail fins to provide lateral thrust. Supposedly, it was to give a top speed of 1,700 miles an hour, cruise at 60,000 feet, and carry up to 135 passengers. To deal with the extreme forces and temperatures of Mach II flight, the aircraft comprised of an internal pressurized cabin that was mounted in a framework, with the outer skin itself mounted on a second framework. These two frameworks were connected together by sliding joints to allow for thermal expansion during flight. Aside from information provided by the patents, further specific information on the aircraft is almost impossible to find. Most of it comes from promotional articles from publications such as Aviation Week and Flight Global. It was only a speculative design, and for the 1950s it must have seemed almost impossibly futuristic. These were of course not the only strange aircraft to never make it past the drawing board. Indeed, there are many more designs out there that deserve coverage, so stay tuned for a continuation of this video series in the future. Next time, we'll be looking at some of the weird and wonderful military projects that didn't make it into production. But until then, I hope you all enjoyed this little foray into the world of hypothetical designs, and thank you for watching.